Welcome back. In today's lesson, we are going to work on solving multiplication and division equations. This is an extension of what we did last time with addition and subtraction equations. And last time we had an addition and subtraction property of equality, and now we will also add to that the division property of equality, which says that whether we have numbers or an algebraic expression, we can divide both sides of an equation by the same number and not change the equality of that expression. So let's see how that works with solving equations. Here's an equation. It says 150h equals 675. First thing we always want to do is rewrite the equation. Remember, our goal is to get the letter or the variable by itself. When we have a number next to a letter, that is multiplication is implied. So the h is being multiplied by 150. Now we need to undo multiplication. To undo multiplication, we use division. They are inverse operations. So whatever we do to one side, we must do to the other side of the equation as well. So to get rid of that 150, we need to divide both sides by 150. So we're going to show that by using the fraction bar. That means divide 150. And when we divide 150 by itself, that cancels and we just get 1. So we still have our letter h right there. So we want to write that as h equals. Now in this right hand side, you can go ahead and use a calculator to divide that out. 675. Remember, the fraction bar means divide, so you'll punch in your calculator. 675 goes first. It's always the number on top first. Divided by 150, and that gives you 4.5. So that says h equals 4.5. Here are a couple for you to try. This is a good idea to pause the video, and I'll give you the answers when you come back. All right, I hope you tried those on your own. The first one, letter A, we have 8x equals 72. So x is being multiplied by 8. So to undo that multiplication, you want to use division. So on both sides, we want to divide by 8, divide by 8. And remember, those 8's will cancel. So we're left with x equal to 9. 72 divided by 8 is 9, and hopefully we got the right answer. There we go. So there's letter A. Letter B, we have minus 4n equals 28. n is being multiplied by negative 4. So we want to divide by whatever number it's being multiplied by. If there's a negative, include the negative. And we do exactly the same thing to both sides. All right? So negative 4 divided by negative 4 is a positive 1, but we still have our letter n, and that is equal to 28 divided by negative 4. Remember, a positive divided by a negative, the signs are different, so my answer will be negative, and 28 divided by 4 is 7. So letter B, hopefully we did that right, and we should have negative 7. And lastly, letter C. Let's take a look at that one. Letter C says negative 12 equals negative 6k. Well, we want to get k by itself. It's being multiplied by negative 6, so we want to divide by negative 6 on both sides. Whatever we do to one side, we must do to the other. And these negative 6's divide each other out, and they end up being a 1. So we have k on the right-hand side is equal to, now this time we have the same signs, they're both negative, so our answer will be positive, and 12 divided by 6 is 2. So let's check letter C. We get k equals 2. So just like we had the addition and subtraction and division property of equality, we also have the multiplication property of equality, saying that we can multiply either side of an equation by the same number without changing the equality of the expression. So we'll use that when we're solving division equations. So here we have a problem. It says a divided by negative 3 equals negative 7. What would the value of a have to be for that to be a true statement? Well, if a is divided by negative 3, we undo division using multiplication. So if it's divided by negative 3, we're going to do the opposite and multiply by negative 3. And make sure we do that on both sides. Whatever we do on one side, we must do on the other. Now when we multiply by -3, the -3 in the denominator and the -3 we're multiplying by cancel out, and they actually give us ones. And 1 times anything is just the number that we're multiplying by. So we get A equals positive 21. Remember, two negatives, those are the same sign when we're multiplying, so we get positive 21. Here's another opportunity for you to pause the video, see if you can figure these out on your own. All right, I hope you gave those a try. Let's take a look. So letter D, we have y divided by -4 equals -8. And if y is being divided by -4, we undo that by multiplying by -4. So I'm just going to write it above here, multiply by -4. And then I'm going to take this side times -4. So these -4's will cancel on the left, and we still have the variable y. Now on the right hand side we have a negative times a negative. The signs are the same, so it'll be a positive number, and 8 times 4 is 32. Check our answer for letter D, positive 32. All right. Let's move on to letter E. Letter E says m divided by 5 is -9, so we want to multiply both sides by positive 5. Positive 5. Remember, the parentheses imply that you're multiplying. So now those 5's cancel on the left-hand side. That was a multiplication sign. It's not a negative. It's a dot for multiply, okay? And those become 1's. So I just have the letter M is still there. A negative times a positive is a negative, and 9 times 5 is 45. So letter E should be -45. So far, so good. Last one here. Let's take a look at this one. 30 equals B divided by -2. Well, we need to multiply by -2. Whatever we do to one side, we must do on the other side. And don't forget we're multiplying. So now these -2's will cancel on the right-hand side, and we still have that letter B over there. And then -2 times 30, a negative times a positive is a negative. And if we double 30, we get 60. So we should have -60 for our answer there. And we do. So we're doing a good job so far. Here's an example, a real-world example with reptiles. It says an adult lizard is about 5 times as long as a hatchling. If an adult lizard is 11 centimeters long, about how long is a hatchling? Well, the adult length is going to be 11, right? They told us an adult lizard is 5 times as long as a hatchling. The adult lizard is 11 centimeters. I should have highlighted that in pink for you there. It's 11 centimeters. And it's 5 times as long as a hatchling. So here's our equation. 11 equals 5 times g, where g is the length of the hatchling. I have no idea why they chose the letter G. You can pick what you want. So if that's our equation, how do we solve that? Well, remember, we're trying to get the letter by itself. It's being multiplied by 5, so we do the opposite operation, divide by 5. Those 5's cancel each other out, and I get G equals 2.2. So that tells us the lizard hatchling is about 2.2 centimeters long. And one of the things you can double check, remember the adult is supposed to be bigger and it was 11, make sure your answer makes sense. 2.2 is smaller than 11. If we had come out with 22 here, we would know that we made a mistake. Here are some problems for you to try on your own and bring to class, and we'll see you next time.